Welcome, everyone, to today's Explainer. I am absolutely thrilled to walk you through a fascinating platform called HumAL. Now, if you've ever spent time looking at IT support workflows, you already know how incredibly complex and bottlenecked they can get. Well, HumAL is specifically designed to completely overhaul and improve those workflows. Today, we're going to see exactly how it combines machine learning predictions with expert human feedback to create a smarter, highly efficient system for routing and resolving your support tickets. Here's a quick look at our roadmap for this explainer. We'll start with smarter ticket routing, move into the active learning workflow, touch on RAG-based response support, take a peek inside the system architecture, and finally wrap up with optional explainability. Okay, Section 1, Smarter Support Ticket Routing, the Problem and Solution. Let's dive right in by establishing the universal pain point facing support teams everywhere. Whenever a new request hits an IT desk, the very first and often hardest hurdle is simply figuring out who is actually supposed to handle it. Traditionally, organizations have had to manually label every single historical and incoming ticket just to train their dispatch systems. Honestly, that's a process about as fun as watching paint dry. Not to mention a massive waste of human capital. What HumAL does instead is leverage a targeted active learning solution. So rather than having a human manually review everything, the system's active learning identifies only the most high-value, uncertain tickets for an expert to look at. And that really brings us to the core mission of the platform. The goal here is to efficiently classify and route tickets to the correct dispatch team without wasting that precious human effort. I want to be super clear about this. HumAL isn't just some generic human-in-the-loop tool where humans are just sitting there supervising a machine. It's a highly targeted active learning engine specifically built for ticket dispatch prediction. The human feedback is strictly the mechanism that fuels and supports this entire active learning process. Moving on to Section 2, the active learning workflow, fueling the engine. So how does that mechanism actually work in practice? Let's explore how human feedback acts as the strategic fuel for this engine. Let's just walk through the life cycle of an unlabeled ticket. Step 1. Incoming unlabeled tickets are processed, and the model attempts to predict their categories, or basically figure out which dispatch team should get them. Step 2. The system analyzes those predictions and prioritizes the tickets it's most uncertain about. Then Step 3. An expert steps in through the dispatch labeling interface, reviews the ticket description, and assigns or corrects the label. Finally, Step 4. Those corrected labels are fed right back in to retrain the model. This continuously improves future dispatch predictions. The experts literally only spend their time where the machine actually needs help. Now, you might be wondering, how does the system actually decide which tickets are uncertain? Well, it comes down to some highly specific mathematical query strategies. It selects the most informative batch of tickets for the human expert, using strategies like least confidence, where it just picks instances with the lowest prediction confidence. There's also margin sampling to find the smallest gap between the top two predicted classes, entropy to look at prediction variance, and query by committee to measure ensemble disagreement. This underlying math is exactly what makes the active learning so efficient. All right, Section 3, RAG-based response support, a parallel capability. Let's shift gears slightly and talk about how HumAL handles the actual responses to these tickets once they've been routed. To do this, HumAL uses something called Retrieval Augmented Generation, or RAG for short. I want to explicitly set a boundary here, though. RAG is a distinct, related support capability. It operates strictly outside the active learning machine learning pipeline we just talked about. It is a completely separate feature meant specifically to draft automated first reply responses for the human agents. So here is how that RAG feature actually streamlines ticket resolution. When a ticket comes in, the system dives into the knowledge base to find similar past tickets. It retrieves their historical resolutions, and then it uses a large language model, specifically GPT, to generate a contextually appropriate draft response based on those past successes. This allows human agents to instantly verify similar tickets, efficiently edit the drafted response if they need to, and then just send it off. And brilliantly, those agent edits and approvals are captured to improve future retrieval quality and response relevance. For your support teams, this is huge. It means the system actually learns your company's specific tone and successful resolution habits over time. Section 4. Inside the system architecture, under the hood. Now that we understand what the platform actually does, both the active learning routing and the RAG response generation, let's see how it's structurally built. If you trace the data flow here from the bottom up, you'll see unlabeled tickets residing in the min.io storage layer. Those flow up into the core active learning component, where the query strategy selects a batch of tickets based on model uncertainties. Those specific tickets are then pushed up to the user interface for the human expert. The expert provides the correct labels, and those labels flow right back down to the model, which is retrained on every new batch of labeled tickets, pushing the updated metrics back into storage. It's really a beautifully clean loop. And the system is entirely modular. It keeps the developer components, like the API, the continuous machine learning pipelines, and those min.io data storage layers, perfectly organized and totally separated from the React front end. This ensures the end user working in the Dispatch UI is never overwhelmed by the back-end complexity. Section 5, Optional Explainability and XAI. Before we wrap up today's explainer, we definitely need to clarify the role of explainable AI, or XAI, within the HumAL ecosystem. The absolutely crucial point here is that XAI is an optional layer. While HumAL can integrate with external explainability services like Lime, it's meant to support expert review and auditability. It is absolutely not a core, built-in dependency that the active learning loop relies on to function for every single prediction. However, when compliance or auditability is required, these Lime explanations are incredibly helpful. They provide a visual representation of the model's logic. They highlight the exact key terms in the ticket description that influence the machine, and they show the mathematical weight of each feature. This helps the human experts understand exactly why a specific dispatch prediction was made. So, if your organization operates in a highly regulated industry, this optional layer is what ensures you can actually audit and trust your AI's decisions. And that brings us to the ultimate takeaway from the documentation we've explored today. If you remember just one thing from this explainer, let it be this. HumAL uses active learning and human feedback to continuously improve dispatch prediction, while RAG-based response support helps agents produce better responses faster. It fundamentally changes how support desks operate. But it leaves us with an exciting question to ponder. If an AI can perfectly predict where your work goes and even draft the resolution, what incredible, high-level problems will your human experts solve with all of their newly freed time? Thank you so much for learning with me today.